Hello everyone, this is Shivam Thakur of Section 3 ABSIT Ghaziabad is here to give you a virtual representation with my friends Tushar Saxena, Sakshi Yadav and Varnika Tyagi on the topic nuclear energy, the future of nuclear power as an energy resource. So let's get dive into the presentation. So the main question is, what is nuclear energy, right? So basically it is a powerful source of energy which is generated during a nuclear reaction by the change in nucleus of an atom. The source of nuclear energy is the mass of nucleus, and the energy which is generated during a nuclear reaction is due to the conservation of mass into energy. And this energy must be released in order to make electricity. So types of nuclear energy. By looking at the picture, we can clearly say that there are two types of nuclear energy: nuclear fission reaction and nuclear fusion reaction. In nuclear fission reaction, as its name suggests, a heavy atom, when bombarded by nuclei, gets split into smaller or lighter elements. Whereas in nuclear fusion reaction, two or more lighter elements, when fused into one another, to make a heavy radioactive element. Okay, so there are some difference between nuclear fission and nuclear fusion reaction. Let's talk about it. In nuclear fission reaction, the nucleus of heavy radioactive elements like uranium, plutonium, or thorium splits into smaller nuclei when bombarded by low energy nuclei. Whereas in nuclear fusion reaction, it involves the combination of fusion of two light elements to form a heavier element and release uncontrollable energy. In nuclear fission reaction, a huge amount of heat is generated during this process, and which is used in nuclear power plant to generate electricity. As we know, in power plants, we used to convert water into steam, and which used to power up the turbines to make electricity, right? So that's why we use nuclear fission reaction process in our nuclear power plants. Did you know that the sun's energy is generated by nuclear fusion reaction? So by this, we can now imagine how much energy would be released in nuclear fusion reaction. That is the source of sun's energy. So that is it from my side. Over to you, Tushar.
Thank you, Shivam. Now I'll proceed further. So let's talk about advantages of nuclear energy. Nuclear energy produces no pollution gases. It does not contribute to global warming. Fuel cost is also very low. Low fuel quantity reduces mining and transportation effects on environment. Power station has very long lifetime. High technology research required benefits other industries. Let's talk about some disadvantages of nuclear energy. Waste is radioactive and safe disposal is very difficult and expensive. Local thermal pollution from wastewater affects marine life. Large-scale accidents can be catastrophic. Public perception of nuclear power is negative. Cost of building and safety decommissioning are very high. Now we'll talk about nuclear reactor. Nuclear reactor is only part of the life cycle nuclear power. The process starts with mining uranium in underground mines. The uranium ore is extracted, usually converted into a stable and compact form. The fuel rod will spend about 3 operational cycles. Here is the schematic diagram of nuclear power plant. Basically, it consists of following parts: cooling tower, electric generator, condenser, turbine, transmission lines, control rods, water pump, etc. On the basis of design, nuclear power plant are of two types: pressurized nuclear power plant and boiling nuclear power plant. So that's it from my side. Now Varnika will proceed further. Thank you.
Thank you, Tushar. Now I will proceed further. Let's talk about some uses of nuclear energy. Space exploration. A great deal of what we know about deep space has been made possible by radioisotope power source. Nuclear energy provides nearly 20% of our electricity in United States. Medical diagnosis and treatment, criminal investigation, and agriculture. Now, coming to the next slide. Here we can see the chart which shows about NPPS. They are irreducible part of carbon-free energy. These are of four types: nuclear, hydro, wind and solar. Let's first talk about nuclear. It is stable and powerful source of baseline energy. It requires large investment for construction. Second, hydro. It is the cheapest energy generation source. Hydro construction required floating large area, possibly for building new facilities are limited. Wind. Relatively inexpensive and powerful generation source. Inexpensive in operation. Generation depends on weather conditions mostly. Solar. It is inexpensive and environmentally generation source. Generation depends on weather condition, many toxic waste in decomposition. So nuclear power along with solar and hydropower shape so-called green square, which may become the base of future energy mix. Let's moving towards another slide. Here we will talk about the scope of nuclear energy. Studies have repeatedly shown that nuclear energy is a low emitting source of electricity production in general. It is also specified low carbon emitting among the low amount of carbon dioxide equivalent per unit of energy produced. It is the second largest source of low carbon electricity production globally and provide about 30% of all low carbon electricity. Almost all reporters on future energy supply from major organizations support and expand role for nuclear power is required. Alongside growth in other form of low carbon power generation is created sustainable future energy system. That's all from my side. Over to you, Sakshi. Thank you.
Thank you, Varnika. I will be continuing from here. Talking about the potential of nuclear energy in India. As of 2009, India envisages to increase the contribution of nuclear power to overall electricity generation capacity from 2.8% to 9% within 25 years. By 2020, India's installed nuclear power generation capacity was expected to increase to 20 gigawatt. As of 2018, India stands 13th in the world in terms of nuclear capacity. Moving forward with the nuclear reactors in India. As of November 2020, India has 22 nuclear reactors in operation in 7 nuclear power plants with an installed capacity of 6,780 megawatt in 7 nuclear power plants. Now, talking about the impact of nuclear energy on climate change. Nuclear power plants produces no greenhouse gas emissions during operation, and over the course of its life cycle, nuclear produces about the same amount of carbon dioxide equivalent emissions per unit of electricity as wind, and 1/3 of the emission per unit of electricity when compared with the solar. As per the conclusory part, while nuclear power cannot substitute fossil fuels entirely and become the sole sustainable energy resource, it can play a significant role in decarbonizing the production of electricity. Thank you